In this video, we're going to do some programming with if-else statements and also use a cumulative sum to solve a programming problem. So let's imagine that we've been asked to do the following. We're going to write a method named count factors where the method is passed an integer as a parameter and we're supposed to return the number of factors that that integer has, the number of other integers that it can be divided by evenly. So if they pass us 60, we're going to return 12 as the result because the 12 integers listed here on the slide are all factors of the number 60. What we're going to do with that method is we're going to use it to solve a larger programming problem where the user can type in a maximum integer, and then we're going to repeatedly check for prime numbers up to the maximum value. And so in this example output here, the user types 52, and we print all the primes up to 52, and we tell the user how many primes there were and what percentage of the integers in that range were prime. Okay, well, in order to solve this problem, we can go to an editor here and we can talk about the count factors method first. Maybe we'll tackle that part of the problem before we do the prime number computations. Here's our editor. If we're going to count factors, one important skill is to be able to read a sort of written description of a programming task and turn it into a method header. So if this method's name is count factors, the problem here says that it will return the factors of an integer, and the call here, the sample call, shows an integer being passed as a parameter and an integer being returned as the result. So if we're going to translate that into a header, we're going to say, well, it returns an integer, its name is count factors, and you have to pass me the integer that you want me to count the factors of. So you pass me a number, I'll tell you how many factors it has. So now in order to write this code, we're going to basically have to count up all the factors by looking at each integer. Let's look at each integer from 1 to number and see whether it is a factor. And we'll count them. And we'll return the total count that we compute. So how do we do that? Well, it's a variation of a technique described in the book called a cumulative sum. And so let's review for a moment how to do a cumulative sum. Well, imagine that we're being asked a slightly simpler problem, which is just compute the sum of all the integers from 1 to 1,000. Now there's actually a formula for doing that, but let's imagine that we're going to do that in a brute force kind of way. So a silly way to try to solve that would be if we said, well, let's just write out in our code 1 plus 2 plus 3 plus 4 all the way up to, plus 1,000 at the end. Now that would be a little bit silly because we'd have to write out all those integers in our code, but that actually wouldn't work very well at all for something like this problem where we don't even know what the maximum value is until the program is running. So we can't write out all the integers that we're looking for here in our source code. We're going to need something a bit more generalized than that. So this solution is no good. Another solution that's not so good is to try to write a for loop, but to do it poorly. So a for loop would be a better way to capture this repetition of all these range of numbers here. So maybe we'll make a for loop here from 1 to 1,000. That should say 1,000, not 100. And maybe what we'll do is we'll try to add all these numbers into some sum variable. This piece of code isn't correct because basically each of the 1,000 times that this loop repeats, it's going to redeclare a new integer named sum. And each of those integers is deleted as the loop wraps around again. And when we get to this point in the code here after the loop, the sum is gone. There actually is no sum anymore because the scope of this variable is only inside the body of the for loop. And so when we get down to the code underneath the for loop and try to print the value of the sum, it's just not there anymore. So that's no good. In fact, the program doesn't even compile. So what we really need to do when we do a cumulative sum is to declare our sum outside the loop because we only want one sum variable. If you don't want it to be done repeatedly, you shouldn't put it inside the for loop. And then what we do is for each of the integers between 1 and 1,000 here, we will add that integer I to the sum and then restore the result back into the sum variable. So then as that loop is going, sum keeps getting bigger. It first stores 1, and then it stores 3, and then it stores 6, and then it stores 10. As each of the integers from 1 to 1,000 is being added to it, that's the value that sum will have. And so we call it a cumulative sum variable because its value accumulates as the loop is repeating. It goes from 0 to eventually the right answer that we're looking for. And again, the key idea here is that the sum variable has to be declared outside of the loop. Okay, so what does this have to do with factors? Well, if we're counting the factors of an integer, there's going to be some sort of loop that checks each integer, integer I going from 1 to number. And what we want to say is we want to check whether I is a factor of number. So we kind of want to see whether well, that's sort of called I now. See whether I is a factor of this number. And if it is, we want to count all of those up. And eventually we want to return the total count. Well, so what we'd like to know is I a factor of the number? Well, the way you figure that out is whether number can be divided by the I evenly. If I divide number by I and my remainder is 0, that means I is a factor. So what you really want to say there is if the remainder, mod, if the remainder from dividing number by I is 0, then that tells me that I is a factor. So what do I do if it's a factor? That's the tricky part. Well, we just learned about cumulative sums. This is a very similar idea. It's sort of a cumulative count. We want to accumulate the count of how many factors we've seen. So here's the idea. If we declare a variable outside of this loop, count 0, then what we could do is every time we see a factor here, we could say count plus plus. We've seen one more factor now than we had previously seen. And what we're going to do with that count variable is at the very end of our method, when all the code is finished running, we're going to return that as the result of our method. Now see, some students try to write return count here. That's not the right place for this line of code because we have to wait until the loop is totally finished running, because only at that point will the count have really counted everything. It will not have been accumulated fully until the loop is done. So what we want to do is cut and paste this line of code at the very bottom of our method. So after the for loop is done here, but before the end of the method here, we want to return count. So just to see that that's working, let's put a call to count factors here, and let's do the count factors of 12. And I'd like to run that real quickly just to see what we get. Well, we don't get any output because the method doesn't print anything. It just returns the count. So maybe we should system out println the count factors of 12 result. And so we get a 6 there. So it thinks there are 6 factors of 12. I think that's right? 1, 2, 3, 4, 6, and 12. Those are the 6 factors. Just to see kind of how this is working, let's walk through it for a second in the debugger. So let's jump into that method there and see what it's doing. So here we go. We're inside the count factors method now. The number is 12, int count is 0, and so now we start I at 1. 1 number mod 1, 12 mod 1 is 0, so count is incremented to 1. Now I is 2. 12 mod 2, that does divide evenly. The remainder is 0, so we do count plus plus again. Now I is 3, that's also a factor of 12. Now I is 4, that's also a factor of 12. Now I is 5. 12 mod 5 is not 0, so when I step forward, it'll skip that. And when it's 6, it'll go back in. When it's 7, it'll skip it. So I think the next time we'll see it go in there is when I is 12. 12 mod 12 has no remainder, so we'll do count plus plus one last time. Now our loop is done, and the count of 6 is returned, and that's returned back to main. So what main prints is 6. Okay, so we're not quite done with this program yet, though. What we were supposed to do was use the count factors method to figure out how many primes there were in a given range. So the user types in a maximum number, and we tell them how many primes were there up to that number. So it looks like the first thing we need to do is ask the user what the maximum number is, and then read that value from the keyboard. So we'll do that using a scanner. This program already has the import statement to use a scanner. We won't need this call anymore to count factors, but let's ask that user for the maximum number that they want, maximum number. And we'll use a scanner for that. So let's make a scanner console is a new scanner that reads from system in. And here we will ask the console for the next int, and maybe we'll store that as max. Okay, now our goal is to figure out all the prime numbers up to max. So if you look at this output here, these are the prime numbers up to 52. So a prime number is a number that's only factors are 1 and itself. Those are the only factors of a prime number. So actually the smallest prime number is defined to be 2. 1 is not considered to be a prime number. So maybe what we could do here is we could say that the key property of a prime number is that it only has 2 factors. And that's very much related to the method we just wrote, count factors, right? So if we call count factors on this number and it says 2, that means it's a prime number, so we should print it out. So maybe what we could do is we could do a loop over each of the numbers in the range, 1 to 52, and if it's got 2 factors, we'll print it out. So let's try that out. Let's say something like for each integer I between 1 and max, the number that they typed on the scanner, we need to see how many factors does this number have. Well, the number that we're looking at is called I. So I think what we want to know is how many factors does I have? And in particular, we want to know, does it have 2 factors? So if it has 2 factors, then I is prime. Maybe we could even start our loop at 2 here because 1 is not going to ever be a prime number. So if it's prime, what are we supposed to do? Well, we're supposed to print it out first of all. See how it prints all of them followed by spaces. So maybe we could just print it. So let's say system out print I plus a space. And maybe that would be a good start for now. Maybe we could compile that and see where we've gotten. Let's run this thing, a maximum number of 52. Look at that, we've got the right set of numbers there. But there's one more line of output that we're supposed to produce. We're supposed to produce 15 primes and then the percentage of how many primes that was. So the way we find the 15 is we're just supposed to count how many of these guys that we're printing as we print them, right? We already did a counting concept when we wrote the count factors method. So we had int count equals 0 and we did count plus plus. So you can use another one of these cumulative loops here out in the main method to figure out how many primes there were. So you can do something like int prime count equals 0. And then when we find a prime number here, like inside this if statement here, we can say prime count plus plus. And now again, once the loop is done, we will have accumulated all the count of all the primes. So we can say something like system out println prime count primes. Let's try that out and see how that works. So 52 produces 15 primes. It's on the wrong line there. We have a lot of these partial prints that don't produce a full line of output. So if we want to end that line, we should probably put a blank println here. Let's run that one more time. If I give 52, okay, we've got 15 primes. That's the number of primes we were supposed to get. The last thing was, what's the percentage? Well, how do we get the percentage? It's basically just 15 out of 52 because, out of that range of 52 integers, 15 of them were prime. So if I wanted to say 28.84% like that, we want to say something like plus the number of primes we found was prime count divided by the total number of integers there is max, and then there's a percent sign after that. But you might be ahead of me. You might be thinking that this actually isn't going to do the right thing. Let's run that real quick and just see what we get. Let's type in 52. It says we got 0%. Uh-oh. So I think you may already know the problem. What's going on here is that we're dividing integers. So if I take 15 divided by 52 in integers in Java, that's going to produce a result of 0 because it's the wrong type. So I think what we want to do is we want to pull this out. This is just kind of getting to be a complicated expression here. So maybe we could just compute the average as a double, or excuse me, not the average, the percentage, like that. That alone is not going to make this computation do the right thing, but what we can do is we can introduce a typecast. We'll say I want to convert prime count into a double for this division, and then divide the double value by max. And so that should produce the right type. The other thing is that we're probably going to be off by a factor of 100. So we could run this real quick and see what we get. But oops, I've forgotten to write percent here in the line of output. So let's run that and see what we get. 52. So here we go. We've got, it looks like we're pretty close, 28846, and we're supposed to get 28.84%. So I think this really should be, 100 times prime count over max. Or a little bit shorter way of saying the same thing would be, instead of casting to a double, we could just say 100.0, because once we introduce that, then everything else that gets mixed with that becomes a double as well. The one last thing that we haven't got here is we haven't got the rounding. So actually, if I run this as is, we'll get all the right numeric computations, but we don't have a very well rounded double value. There's a couple different ways you can round that off. One way you could do it would be to numerically round when you're computing the percentage here, and another way would be to use system out printf. I think we're going to use the printf solution because that's a little bit cleaner. Printf is kind of tricky in the syntax, but system out printf statement, basically you write out the entire string that you want to be printed like this, and then everywhere you want to insert a variable, you use a percent sign and the type of the variable. A D is for a decimal number like an integer, and an F is for a floating point number like a real number. We've got a percent sign here, and you actually have to write 2 percent signs to sort of escape that percent sign operation, because percentage is used to start these placeholders here. And what you do is after the string is over, you replace all these placeholders with what variable you want it to insert there. So the first one, %d, we want that to be the number of primes, prime count. And the second insertion placeholder is the max, or the percentage here. So prime count, primes, percent. So it's a little bit hard to read. But the other thing that you can do when you do these placeholders here is that you can introduce how many digits there should be after the decimal point. So we'll say this floating point number has a decimal point and 2 digits. That's a pretty terse syntax. The textbook has a little bit more detail about the printf statement and how it works. But this particular program, if we run it now, we'll actually get a nice rounded version of that computation to 2 decimal places. And that's our solution to the program.